You think you know what light is. You flip a switch, the room fills with brightness. You turn it off, darkness returns. Simple, obvious, familiar. But the moment you stop taking light for granted, the moment you really ask what light is, everything begins to fall apart. Because when you follow a single photon on its journey, from the surface of the sun to the back of your eye, you don't find anything remotely simple. You find something so strange, so deeply unsettling, that it forces you to abandon almost every intuitive idea you have about how reality works. Light is not a wave. Light is not a particle. And the truth is far stranger than either. Once you understand what light actually is, once you see how quantum mechanics truly operates, you realize that the universe does not behave the way your brain evolved to expect. Not even close. Let me show you why. We begin somewhere familiar. In the 17th century, Isaac Newton sits alone in a darkened room. The curtains are drawn tight. The outside world is shut out. In the fabric covering the window, he cuts a tiny hole. Through it, a thin beam of sunlight enters, narrow, brilliant, perfectly white. He places a glass prism in the path of the beam, and the light explodes. It spreads outward like a fan, painting the wall with a perfect spectrum: red, orange, yellow, green, blue, violet. A flawless rainbow, frozen in place. Prisms were not new. People had seen this effect before, but everyone believed the same thing: that white light was pure, and the prism somehow stained it, corrupted it, introduced color where none existed before. Newton wasn't satisfied, so he did something deceptively simple and profoundly revolutionary. He took that rainbow and passed it through a second prism, inverted, and the colors recombined, perfectly, cleanly. White light returned, unchanged. Think about what that means. The prism was never adding color. White light was never pure. White light was already complex. It was a mixture, a hidden blend of all colors combined. Each color bends by a different amount as it passes through glass. Red bends the least. Violet bends the most. The prism doesn't create colors. It separates them, sorts them, reveals what was already there. Newton went further. He isolated a single color, red, and sent it through another prism. Nothing happened. It stayed red. No further splitting. No hidden components revealed. Red light was fundamental. He repeated the experiment with every color. Green stayed green. Blue stayed blue. Each color was indivisible. This wasn't just a clever optical trick. It was the first real clue about the nature of light itself. Newton concluded that light was made of tiny particles, corpuscles, fired from luminous objects like microscopic cannonballs. It made sense. Light travels in straight lines. It casts sharp shadows. It reflects off mirrors like a ball bouncing off a wall. But there was a problem, a fatal one. A century later, Thomas Young performed an experiment so elegant and so devastating that it shattered Newton's picture completely. Young took a beam of light and passed it through two extremely narrow slits positioned close together. He projected the result onto a screen. If light were made of particles, the result should have been obvious. Two bright bands, one behind each slit, like bullets fired through two windows, striking the wall behind them. That's not what appeared. Instead, the screen, filled with alternating bright and dark stripes, a repeating pattern, a pattern of interference. This is what waves do. When waves meet, they combine. Crest meets crest, and you get a stronger wave, brightness. Crest meets trough, and they cancel, darkness. Particles don't do this, waves do. And so Young concluded, correctly, that light must be a wave. For the next 100 years, that idea reigned supreme. Light was understood as a wave moving through an invisible medium called the ether, a substance thought to fill all of space. Maxwell's equations of electromagnetism seemed to confirm it. Light was an electromagnetic wave, case closed, except it wasn't. At the turn of the 20th century, physicists encountered a problem so severe it earned a dramatic name: the ultraviolet catastrophe. They were trying to understand how hot objects emit light. Classical physics predicted that as objects heated up, they should emit infinite amounts of high-frequency ultraviolet radiation. They didn't. Reality refused to cooperate. Max Planck found a solution, but it was deeply unsettling. He proposed that light could only be emitted in discrete packets, not continuously, in chunks, quanta of energy. The math worked perfectly. Planck himself didn't believe it was real. He thought it was just a mathematical trick. He was wrong. 5 years later, Albert Einstein showed why. Einstein examined the photoelectric effect. Shine light onto a metal surface, and electrons are sometimes ejected. But something strange happens. Bright red light does nothing. No electrons move. Dim violet light, barely visible, ejects electrons instantly. Intensity doesn't matter. Frequency does. Einstein proposed something radical. Light arrives in packets, photons, and each photon carries a specific amount of energy determined by its color. Red photons carry less energy. Violet photons carry more. To eject an electron, a single photon must carry enough energy. Millions of weak photons won't help. Just like throwing cotton balls at a window won't break it. You need a stone. Einstein was right. He won the Nobel Prize for this, not for relativity, but for proving that light behaves like particles. So which is it? Wave or particle? Both answers are wrong. And now reality becomes truly disturbing. Repeat Young's double-slit experiment, but dim the light until photons pass one at a time. One photon, one dot on the screen, another photon, another dot. Particles. But wait long enough, and something impossible emerges. The dots slowly build up an interference pattern. Each photon went alone. There was nothing to interfere with. And yet, interference appears. Each photon behaves as if it passed through both slits at once and interfered with itself. Try to catch it. Place detectors at the slits. Measure which path the photon takes. The moment you observe it, the interference vanishes. Now you see particles. Observation changes reality, not metaphorically, literally. And from here on, nothing about the universe is ever simple again. Because this is not a trick. It is not a flaw in the experiment. It is not a limitation of our instruments. It happens every single time. Photons do it, electrons do it, atoms do it, even large molecules do it. Whenever you allow a quantum object to remain unobserved, it behaves like a wave, spreading out, interfering with itself, exploring multiple possibilities at once. The moment you force it to reveal information about its path, it snaps into something particle-like. One place, one outcome. The universe behaves differently when it is watched. This is where language starts to fail us. Before measurement, the photon does not go through the left slit or the right slit. It is not secretly choosing one while hiding the answer from us. It genuinely does not have a definite position. It exists in what physicists call a superposition. Multiple mutually exclusive states at the same time. Not metaphorically, not as a lack of knowledge. Literally. The photon is not somewhere until something forces it to be. Measurement is not passive. It is not simply looking. Measurement is an interaction, a physical process that entangles the photon with the measuring device, with the environment, with the rest of the universe. That interaction destroys the superposition and leaves behind a single outcome. This is called wave function collapse, and no one truly understands why it happens. Richard Feynman, one of the greatest physicists who ever lived, put it bluntly: I think I can safely say that nobody understands quantum mechanics. He wasn't being modest. He was being precise. We understand how to calculate. We understand how to predict. We do not understand why reality behaves this way. And yet, those predictions are absurdly accurate. Quantum electrodynamics, the theory describing how light and matter interact, produces numbers that have been confirmed to 11 decimal places. 11. That level of precision is almost beyond comprehension. It's like measuring the distance from New York to Los Angeles with an error smaller than the width of a human hair. So whatever this strange picture of reality is, it is not optional. The universe obeys it with ruthless consistency. Now here is where the story becomes even stranger. Suppose you want to calculate the probability that a photon travels from a source to a detector. In classical physics, you would ask, what path does it take? In quantum mechanics, that question has no answer, because the photon does not take a path. It takes every path. Every possible trajectory connecting the source and the detector contributes to the outcome. Straight lines, curved paths, paths that loop wildly through space, paths that wander away and come back, paths that, mathematically speaking, go to Mars and return. All of them. Each path contributes a quantity called an amplitude, a complex number that contains both magnitude and phase. To get the probability that the photon arrives at the detector, you sum all of these amplitudes and then square the result. This sounds insane, and yet it works. When you do the math, classical behavior emerges naturally. Reflection, refraction, diffraction, all of it falls out of this principle. The reason light appears to travel in straight lines is not because it only takes the shortest path. It's because the contributions from paths near the shortest time path reinforce each other, while contributions from wildly different paths cancel out through destructive interference. But when the geometry allows those paths to reinforce rather than cancel, as in the double-slit experiment, the wave nature reveals itself. So light is not choosing between paths. It is exploring all of them. And most of them simply erase each other. What remains is what you observe. This is not philosophy. This is how lasers work. This is how fiber optics transmit information. This is how semiconductors function. Your phone works because electrons can exist in superpositions. Your computer works because electrons can tunnel through energy barriers they should never cross, according to classical physics. Transistors depend on quantum behavior. Without it, modern civilization collapses instantly. The sun shines because quantum tunneling allows atomic nuclei to overcome electrical repulsion and fuse. Without quantum mechanics, nuclear fusion would not occur at the temperatures inside the sun. Without fusion, there is no sunlight, no warmth, no life. Every atom is stable because of quantum rules. Electrons do not spiral into the nucleus because only certain energy levels are allowed. Those discrete levels are not suggestions. They are absolute. Without them, matter would not exist. So this strange, unsettling framework is not an abstract curiosity. It is the foundation of everything solid, everything alive, everything technological. And yet, at its core, it tells us something profoundly uncomfortable. Reality is not deterministic. It is probabilistic. The universe does not decide what happens until it happens. Before measurement, outcomes exist as possibilities, not facts. The equations do not predict what will happen. They predict what can happen and how likely each outcome is. This is not ignorance. This is not incomplete information. This uncertainty is built into the structure of reality itself. When we measure, we do not uncover a pre-existing answer. We force one into existence. And now comes the hardest part to accept. The measuring device is not special. The observer is not special. Consciousness is not required. Any interaction that extracts information with air molecules, with light, with a detector, can trigger collapse. The universe is constantly measuring itself. So where does that leave us? It leaves us in a universe where objects are not things in the classical sense. They are not tiny billiard balls with definite properties waiting to be revealed. They are mathematical objects, wave functions, encoding probabilities, potentialities, tendencies. They exist as clouds of possibility until interaction crystallizes them into events. And this is where the story loops back to light itself. Light is not a wave in space. Light is not a particle moving through space. Light is a quantum object, something that has no classical analogy. It behaves like a wave when allowed to spread and interfere. It behaves like a particle when forced to localize. But in itself, prior to measurement, it is neither. It is more fundamental than either description, and that realization breaks something in the human mind, because our intuition is built from a world of solid objects and continuous motion. Quantum reality is neither solid nor continuous. It is discrete, probabilistic, and deeply non-intuitive. And yet, it is real. Newton showed that white light is composed of colors. Young showed that light interferes. Einstein showed that light arrives in packets, and an entire generation of physicists, Bohr, Heisenberg, Schrödinger, Dirac, Feynman, uncovered the rules governing this strange domain. A century later, we still do not know why the universe works this way. We only know that it does, and that may be the most honest thing physics has ever told us. Physics, at its deepest level, is not a story about certainty. It is a story about limits, about how far questions can be pushed before the universe stops giving intuitive answers and starts responding only with mathematics. And light sits right at that boundary, because light is where classical intuition finally breaks beyond repair. You see, everything about our daily experience trains us to think in terms of objects. Things have positions. Things have velocities. Things follow paths. Causes produce effects in clean linear ways. But light refuses to obey that logic. A photon does not have a trajectory in the classical sense. It does not occupy a single point in space unless forced to. It does not even meaningfully exist as a localized object until an interaction pins it down. Before that, it is described entirely by a wave function, an abstract mathematical entity that does not live in ordinary space, but in a space of possibilities. This is why attempts to visualize quantum behavior always fail. Any picture you draw is already wrong. The wave function is not a physical wave sloshing through space. It is a tool that encodes everything that can be said about a system, and nothing more. And when you measure, you don't reveal a hidden reality. You create one. This idea alone is enough to destabilize centuries of philosophical assumptions. It means that the universe is not a machine ticking forward with predetermined outcomes. It means that at the deepest level, reality is not a list of facts, but a spectrum of probabilities. And light is the cleanest, purest example of this truth. This becomes even clearer when we look at polarization. Light waves oscillate. But oscillate in what direction? It turns out they can oscillate in many orientations. When you pass light through a polarizing filter, you restrict those oscillations to a single direction. Classically, this seems simple, but quantum mechanically, polarization behaves like a two-state system. A photon polarized vertically is not partly horizontal, it is fully vertical. But if you measure it in a different orientation, say diagonal, the outcome becomes probabilistic. You don't uncover what was already there. You force the photon to choose. This leads to phenomena like quantum entanglement. Take two photons created together in a single quantum process. Their properties become linked. Measure the polarization of one, and the other instantly assumes a corresponding state, even if it is light years away. No signal travels between them. No information is transmitted faster than light. And yet the correlation appears instantaneously. Einstein famously called this spooky action at a distance. He hated it. He believed reality must be local and deterministic, that quantum mechanics must be incomplete, that hidden variables must exist beneath the randomness. He was wrong. Experiments have ruled out local hidden variable theories. Reality really is non-local in this subtle, constrained way. Entanglement is not a bug. It is a fundamental feature, and light is one of the easiest systems in which to observe it. Entangled photons are now routinely created in laboratories. They are used in quantum cryptography, quantum teleportation, and tests of the foundations of reality itself. And yes, quantum teleportation is real. Not the teleportation of objects or people, but the transfer of quantum states. The information defining a quantum system can be transmitted from one location to another, destroying the original in the process, without moving the particle itself. Again, not science fiction, demonstrated fact, and all of this flows from the same strange core principle. Quantum systems do not possess definite properties until measured. Light, at the most fundamental level, is not stuff. It is not a thing in the way a rock is a thing. It is an excitation of a quantum field, the electromagnetic field, a ripple in something that exists everywhere, even in empty space. Empty space is not empty. It seethes with fields, with fluctuations, with virtual particles constantly appearing and disappearing. Light is one expression of that deeper structure. And this brings us back to something profoundly important. Light is not merely how we see the universe. Light is the universe revealing itself. Every atom interacts through electromagnetic forces. Every chemical bond is electromagnetic. Every biological process depends on electron behavior. Vision itself is a quantum process. Photons strike retinal molecules, triggering electron transitions that cascade into nerve signals. You are not passively observing light. Light is physically reshaping matter inside your body. And despite all this understanding, despite the equations, the experiments, the technologies, the central mystery remains untouched. Why does any of this exist at all? Why does the electromagnetic field exist? Why do photons exist? Why do the laws take this form and not another? Physics does not answer these questions. It never has. Physics tells us how the universe behaves, not why it exists. It uncovers patterns, not purposes. And when those patterns are pushed to their limits, we encounter something like a wall, not of ignorance, but of humility.